This is video number 18 for the playlist of 3D Experience CATIA Generative Shape Design Application, release 2026x. Please note that there are two playlists for this application at this point. One of them is the wireframe, which has 59, 60 videos in it, and this is the one that says Surface Tab. There will be other playlists associated with other tabs, but this is the Surface tab playlist. The particular video is going to be discussing the area law option, which you can find in the multi-section surface icon. The ribbon at the bottom of the page for GSD looks like that, and there is a surface tab here, and you can reach the multi-section surfaces through this pull-up menu. Upon clicking on that icon, this dialog box opens up, and what we want to do is discuss one of the options in the advanced tab, advanced options. When you expand the advanced option, you get a whole whack of things to do, and the one that we're going to be discussing is what is called area law. There's a caveat here in the help which says that you must have these licenses in order to be able to use area law, which is fine. Now, and there's some help there, but let me go ahead and explain what the story is. First of all, you need a law, and to create a law, you're going to have to go to within the generative shape design ribbon. From surface, you're going to go to the transform tab, and you scroll to the right, and you find the law. And when you click on the law, it asks you for two sketches. For example, in addition to the multi-section surface that we will be defining later on, you need two sketches, and these two sketches at the end of the day looks like that, separate sketches. One of them is a horizontal, for example, line. All there is to it, the actual length is irrelevant. And the second sketch, which is kind of constructed on top of this, is the variation of the equivalent radius of the cross section as you go from one end to the other end. Now, what does that mean? So suppose at one end we have a section 1, some area. If you find the area associated with that section, it should be pi times radius squared, whatever the height is. For example, if radius is 1, the equivalent area at that end is pi r squared, pi times 1, which is 3.14. So at one end, the section area, whatever it is, the shape of it doesn't matter. Doesn't have to be circle, doesn't have to be any particular. The area of that section should be 3.1415, 3.14. As you travel down the line to go to the other section, the radius, equivalent radius at the other section, for example, in this drawing, is r equal to 2. Remember, this doesn't have to be 1 and 2. I'm just giving you an example. What does that mean? So at the other section, the section 2, the radius is equivalent radius is 2, so the area of that equivalent circle is pi r squared, which is 3.14 times 4, which is 13.56. So at one end, the area should be 3.14. At the other end, the area, whatever shape it is, should be 13.56, which is 4 times, pi times 4, which is pi times radius squared. Now, this curve gives you the variation as you go from one end to the other end. So in this particular case, for example, what that means is that halfway along the way, the equivalent radius is 1, and then after that, the equivalent radius increases, and at the other end, the equivalent radius is going to be 2. Remember, it doesn't mean that the end sections must have circular radii. Okay, we'll do an example. Now, the horizontal sketch goes into reference in that dialog box, and the sketch which is on top of that, the variation, goes into sketch 2. Okay, let's move on. When you do that, for example, in this particular problem, one end of it, I made a rectangle of area 3.14. In other words, height of, for example, 3.14, width of 1. At the other end, I just happen to make a circle. It doesn't have to be a circle. It can be anything. As long as the radius of that enclosed section is pi times radius squared. In other words, pi times 2 squared. In other words, pi times 4, which is 13.56. So what happens is that when you import the law, area law, this shape will be performed. And notice that what happens, the area at one end is pi, the area at the other end is 4 pi, and it is arranged so that the equivalent radius, in other words, if you take a cross section here and find its area, and you pretend that it's pi times some radius squared, the radius is going to come from that curve that I just showed you, that variation that I just showed you. I know it is rather awkward, confusing, but that's why if you're into this business and you use this kind of a feature, it's useful. Otherwise, average people will not be using it. I'm using the instruction in this webcast, very good webcast, except that it's maybe 5 years old and dialog boxes look different. I'm using the release 2026x. Okay. Once I'm done with this video, the only two items that I have not discussed in the in the multi-section surface are these two items. This item I did not discuss, and this item I did not discuss. The main reason is that it's very, very vague in the help menu on what it's actually doing. I mean, if you can make sense of it, that's great, but I found it difficult to decode what they're saying. Okay? All right. So once I'm done with this, then we have done quite a few videos on this particular multi-section surface with all the options that I can find, except those two that I just mentioned. Okay, we are in the 3D experience interface. So what I'm going to do is create a plane here, because this plane, which is, I'll make it 10 meters away, is going to have that rectangular section on it. There. So on that plane, I will sketch the section that is rectangular. I'll make my job easier, make it a centered rectangle. And let me dimension this thing to be 1 meter. And dimension this side edge to be pi, big pi. I can write 3.14, or I can write type big P, big I, which automatically CATIA knows that 3D Experience CATIA knows that it is 3.1415, etc. So the area of this rectangle is 1 times pi, which is pi. As if we had a circle of radius 1 instead of a rectangular section. So that'll give you the same area. Exit. Good. Then I'm going to draw my circle of radius 2 at this end. I can go and draw another shape. It doesn't matter, rectangle, as long as the area is 4 pi. But instead of doing that, I'll make a circle. And I dimension the radius to be 2, which means automatically the circle is going to be having radius pi r squared, which is 4 pi. There we are. And why am I doing this thing? Because my law goes, this thing that I'm going to introduce later on, from radius 1, equivalent radius 1 to equivalent radius 2. So area of pi to area of 4 pi. Okay. Now, as far as the the law is concerned that I'm going to need, I can do it in these planes, but I'd rather do it at a different plane. So I'm going to create an offset plane from this, and let me make this thing 4 meters away so that I can see it actually. I'll make it -4. So I'm going to draw my line, my law in this plane. So I need 2 sketches, one for the reference, the other one for the variation. So what that means is that on that plane, I will sketch a horizontal line starting from the origin, horizontal line, and I give it a dimension 4 meters, just arbitrarily, 4 meters. That dimension doesn't matter. Notice that I'm saying that this actual length is irrelevant. I made it 4. And exit. Then I'm going to do the variation on the same plane, a different sketch. I will draw that broken line segment like this and dimension it so that we get what we want. So the distance from here to here, I want it to be 1. This dimension to be 2, because I want the radius essentially to change halfway through. Dimension from here to here to be 4. And finally, the height, this height, the dimension from here to the horizontal segment to be 2. So basically this, what you see there, if I exit that, what you see there, these 2 sketches, these 2 sketches essentially gives you that. It doesn't matter which plane you draw it to, but okay, very good. So let's go ahead. Now we're going to go to wireframe. Oh, I have to create my law. I created the 2 sketches, but I have to do my law. There is no law here. You can see that. So you go to the Transform tab, scroll down, you find the law here, you click on it. It says, what is the reference? The reference sketch 3, that's the horizontal line. What is the variation or definition? Sketch 4, that's the broken line. And then you say, okay, so I do have a law here. Now we go to the Surface tab, multi-section. Let's see. For my first section, I select this rectangle. For the second section, I select this circle. And if I say preview, of course, I get something that is a multi-section surface that goes from this rectangular section to circular section. Now, you go to area law, down here, see that? Area law, and you select the law that you created, recreate it, and then say view, preview. There we are. And what you get is this. And then say, okay. Some of the stuff that you don't need, you can hide. For example, let me hide all these planes. Let me hide this, hide that. Hide this sketch. This law, I don't want it, but if you want, I can leave it there, or I can hide it. It doesn't matter. So let me go ahead and hide it. Where did that go? All these sketches. Yeah. So what's happening is this. At this end, I have a rectangular cross section whose area is pi, which means if this was a circle, it would be a radius 1. At this end, I have a circular cross section whose radius is 2. And the area of this multi-section surface changes so that the area of these sections up to that point, any section that you take will have an area of still pi. You might say, well, it's narrowing down. How come it's narrowing down and still has the area pi? Because if you look at it from the inside, it's actually bulging out. So the area is still 1. And from this point on, the area is not pi. The area increases as the let me put it this way: the area increases according to that linear variation, according to this linear variation. It's actually not linear because what you see is not a linear. This is linear variation of radius. So you give me any location, I look at that location, find the equivalent radius, whatever it has to be from this linear variation, and multiply it by pi to the square of that radius. That's what's happening. This is what area law is. And that curve, by the way, could have been any arbitrary curve if you wanted to. I mean, obviously, if you put garbage in, you're going to get garbage out. It may be that you insist on having it so that there is no such a, this does not apply. It could be that you run into error messages too. So obviously, nothing is completely random in this case. All right, folks, so this is it.